Okay, so a couple things. Now on these, this in the book, this comes under the section that says factoring common monomials first. That's a weird way of saying it. We would just call it greatest common factors, factoring out a greatest common factor first. So when we factor this, what are we going to do first here? Okay, we're going to factor out a 5. Exactly. We want to always try to do that. So if we factor out a 5 or undistribute a 5, whoops, what are we left with?
X squared minus x minus 2 5.
Okay, everybody see that? We're just dividing that away. We're dividing that 5 away from each term. And now it's an easy kind. It was looking harder. We had a 5 in front of the x squared. That's an a times c then split b problem. Those are harder. But once we factor that 5 out, now we've got this blue trinomial to factor, and that's an easy one. I've got a 1 in front of the x squared. So all we need are the magic numbers. What numbers multiply to -2 and add to -1? Almost. -2, +1. There you go. Good. So this breaks up into x minus 2, x plus 1, and then we've just got that 5 out front.
That's the answer?
That's the answer. That's how we'd write it. We've got 3 factors there. The 5, which is a constant factor, and then the 2 factors with the x's in. Okay? Okay, the other thing that people are running into is special patterns. Okay, now there's only one that you really have to know. Okay, special factoring patterns. Oops, can't spell. There we go. Okay, the one that I really want you to be familiar with that's very useful is difference of squares. Difference of squares is any pattern that fits that form. Something squared minus something else squared. And if you ever see that factoring pattern, the answer is really simple. It's always just the factors a plus b times a minus b every time. So we call the conjugate factoring pattern because those are conjugates. We'll talk more about that later. So let's look at an example of that. Look at maybe just a couple quick ones. So what if we had something like we wanted to factor x squared minus 100? Okay. Whenever you see 2 terms that are, instead of 3, 2 terms and there's a minus sign between, you're always looking to see if you can fit it into this pattern. So can I write this as something squared minus something squared?
X squared minus.
Yeah, well, the first one's pretty obvious. X is what's being squared in the first term. In the second term, 100 is just 10 squared. So this is acting like our A. X is like our A in this case, and 10 is like our B, and we're just going to follow that pattern, right? So we're going to get A, which is X this time, plus B, which is 10, right? Times A, which is X, minus B, which is 10. And that's factored. Easy. Okay? Those can look a little more difficult. What if you had something like this? What if you had, say, 25x squared minus 81? Okay, can I break that up into something squared minus something squared? This one's probably the easiest one. 81 is what squared? 9. Okay. Now, what about the 25x squared? There's 2 parts to that. There's the number and the variable. 5x, yeah. Because the square root of 25 is 5, and the x is being squared, right? And so the quantity, 5x, is what's being squared to create 25 times x squared. 5 squared is 25, x squared is x squared. Make sense?
Yep.
Okay, so now our a is 5x, our b is 9, and we'll follow the same pattern. A, which is 5x this time, plus b, which is 9, times a, which is 5x, minus b, which is 9. See how that works? Okay, the other pattern, which I don't care so much about, is this one. This one's a little harder to see, and you can just factor regularly anyway. But if you see this pattern, a squared plus or minus, let's say plus, 2ab, whoops, go back. Or this one equals A plus B quantity squared, and this one equals A minus B quantity squared. So what you're looking for is, like, I'll give you an example. Say you had something like x squared plus 10x plus 25. Okay, what you look for with this pattern is if the constant is something that is a perfect square, like 25, so that's 5 squared, is the term in the middle 2 times that number? Okay, so that's how you're looking for this one. Does that make sense? So this would factor, this fits this pattern if A equals X and B equals 5, right? And so then if you see that pattern, then you just know that's going to be X plus 5 squared. But the reason I'm not so extremely concerned about that, honestly, is that you can just factor those normally, finding the magic numbers. And it's for that reason I don't really care if you work too hard at memorizing these, because it's not that big a deal. What would the magic numbers be? Two numbers that multiply to 25 and add to 10? Is it 5 and no? Multiply to 25 and add to 10. 5 and 5, yeah. So it's just x plus 5 times x plus 5, which we could just write as x plus 5 squared. So these you can factor normally. But these, you really want to know the difference of squares ones. Okay, does that make sense? Okay, not that big a deal. All right, that fills in the little blank we had. Let's go to 205.